All right, good morning, good afternoon. Geometry, if you missed today's class, you missed a rather important lesson that I want you to have, and that's why I'm putting this video on. This Neuropod is up on Canvas right now. Watch this video, watch it simultaneously, and work through the Neuropod. Give yourself a shot at being successful in this class. So let's start out with what's going on here in this opening activity. And there's some things that we need to know. There's some things we need to know. One, we need to ask ourselves, what kind of vertical, I already gave you the answer, but what kind of angles do we have here? And these angles are vertical angles. These are vertical angles. And what does that mean? Well, what that means is that, hey, you know what? This angle is exactly the same as this angle. That's what they mean. They have the same value. So whenever we have two lines that intersect, straight lines, these opposite angles right here that share the same vertice can be considered congruent. Well, that's how we're going to solve this problem. We know that this angle is just some number plus 94. We don't know what that number is yet. That's what we have to figure out. Equals 4 times some number plus 25. So at this point, we're just doing the algebra. What are we going to do? We're going to subtract x from both sides. We're going to subtract 25 from both sides. Remember, what you do to one side of the equation, you do to the other side. And what does that leave us with? 69 equals 3x. We're going to divide both sides by 3. And it gives us 23 equals x. So yes, x equals 23. All right. But we're not done here. What are they asking us to do here? So let's see, in figure shown, AB intersects CD at point E. So here's AB, here's CD. They're crossing right there. Determine the measure of angle AED. So what is that angle AED? We're going to take this x, we're going to plug it in. When we plug that in, what's that? 23 plus 94, which is 117. Because we have vertical angles, if this is 117, that also will be 117. But we're not done. We need to find out what the measure of angle AED is, which is this angle right here, AED. That is our big question mark. Well, if we look at this, we have 4 angles that are going around in a circle. So we know that all 4 of these angles are going to be 360 degrees. We know if we add 117 and 117, it's going to be 234. And if we subtract it from 360, we got 126. So I know there's 2 angles left. We're going to divide them by 2 because they're going to be exactly the same. And that gets us 63. So I know this angle here is 63 degrees. We know that this angle here is 63 degrees. So the measure of angles AED equals 63 degrees. Wow. Think about all the things we had to know. We had to know what it means to have vertical angles. We needed to know that these were vertical angles. We needed to know that all of these angles add up to 360 degrees because we are going around into a circle. We had to know that. We had to know a little bit of algebra. And we had to keep at it. There's a lot of things we're doing. So those are opening activity. Work this out on your own. Let's continue on because our learning targets, here they are. I'll give you a chance to look at it and pause the video. And we're going to work with parallel lines today. And we're going to look at the unique properties of these parallel lines. When we have two parallel lines that are cut by a transversal, that means we have two lines that are parallel, and another line will cut right through it. Unique angles are formed, unique congruent angles, unique supplementary angles. And we're going to take what we know to find out what we don't know. And we're going to prove these things to be true. But first, we need to know a little bit about parallel lines. I highly recommend that you pause this. If you're on the Nearpod, you take a picture of this, you write this down in your notes. You're going to need these. We're going to use these parallel lines for the rest of the quarter, and you need to know these. But let's start out with our congruent angles. Alternate interior, corresponding, vertical, alternate, and alternate exterior. These are our congruent angles. Let's start out with alternate interior angles. And alternate interior angles, they live inside the parallel lines. They straddle either side of the transversal, which is this line that cuts the parallel lines. And notice how they're both acute angles. So if I knew that this angle here was 60 degrees, I also know that this angle here is also 60 degrees. Now, this is not the only set of alternate interior angles that we have. We can also say that these angles here, by definition, are alternate interior as well. So if I know that this angle is 120 degrees, for instance, then I could say that, yeah, these are 120 degrees as well. Let's go on to our next angle, which is corresponding angles. In corresponding angles, you're always going to have one corresponding angles live outside of the parallel lines, and another one's going to live inside the parallel lines. These are difficult ones to spot. Most students really stumble on these, but I always look for a congruent angle that sits outside of the parallel lines and one that sits inside, and they're on the same side of the transversal. We could also say that, hey, you know what? These angles here are corresponding. We can also say that these angles here are corresponding because we got one out, one in, and we can also say that these angles here are corresponding as well. The next one, we worked on those last time we were together. These are vertical angles, and just like the opening activity, if we see two straight lines that intersect like we're seeing here, they create vertical angles. These angles also are congruent. I can say that these angles here are congruent. These angles here are congruent. And these angles here are congruent. These are all vertical angles. We got 4 sets here. Last set of congruent angles are alternate exterior angles. Similar to the alternate interior angles, these exist outside of the parallel lines, and they're on either side of the transversals. So that's the big difference. Alternate interior are inside the parallel lines, alternate exterior are outside the parallel lines. And like alternate interior, we have more than one set. We can say that these 2 angles are also alternate interior angles. So these are our congruent angles: alternate interior, corresponding, vertical, and alternate exterior angles. These angles will always be congruent, meaning they will be equal to each other or the same. All right, now let's get into same side interior. Same side interior is a little bit different than these. These are not congruent angles. And we could see that with our eyeball test, right? We have an obtuse angle here. We have an acute angle here. We could see that they had, these guys, but most importantly, both these angles add up to 180 degrees. Just like the alternate interior angles, they live inside the parallel lines and they exist on the same side of the transversal, hence the word same side, hence the word interior, meaning they live inside the parallel lines. We also have another set of angles as well. And these 2 angles will also add up to 180 degrees. These are also same side interior. Same side exterior, just like same side interior, they're on the same side of the transversal, but they do not live inside like the same side interiors do. They live outside the parallel lines. And we can also say that these angles here are also same side exterior angles. And these are supplementary angles, meaning they both add up to 180 degrees. We can use these. Okay. All right, let's keep going. There's some theorems that we're going to learn. Take a moment to pause this video and get familiar with these theorems. We're going to use all of these theorems to prove other theorems, to prove other things are true. Let's start out with the corresponding angle theorem, which states if two parallel lines are intersected by a transversal, then the corresponding angles are congruent. And we just got finished working with the corresponding angles just a minute ago. One that exists outside and inside. But more importantly, we could also use corresponding angles, not to just to prove that, hey, we have two congruent angles, but we could take the converse of that theorem and say that if we have two lines that are intersected by the transversal and they form corresponding congruent angles, then we could also say that the lines are parallel. What does that mean? You can use corresponding congruent angles to prove that lines are parallel. And throughout these lessons and throughout this unit, I'm going to ask you to prove corresponding angles are true or use corresponding angles to prove that other things are true. But I'm also going to ask you to prove that we have parallel lines are true. You're going to see a lot of this in Mathia. You're going to see it, and it's called the corresponding, what's that word? Let me find it. Angle converse theorem. And what we're basically doing is we're taking the hypothesis of the corresponding angle theorem and we are flipping it around. The corresponding converse theorem states that if two lines intersected by transversals form congruent corresponding angles, then the lines are parallel. So if you can show that the corresponding angles are congruent, and you prove that, you can also use that to prove that the lines are parallel. So let's work on some proofs. In particular, same side interior. And I'm going to give you some time to look this over. Go ahead and pause the video. But what we're going to do is we're going to do a bunch of a series of proofs. And the first one we're going to work on is prove that same side interior works. So here's our given. WX and Z is a transversal. And you'll look real close. We have two vertical lines, two lines next to each other. That means they're parallel. That's our given. They're saying that this line and this line is parallel. And we can see that with the notation with these two arrows. And we can see that the Z is the transversal, is a line that is cutting them. We want to prove that the same side interior angles are supplementary angles, meaning that they add up to 180 degrees. So how are we going to prove that? The way we're going to prove that is we're going to use some congruent angles. Let's start out with, let's use our corresponding angles. We just got finished working with those, right? And we're going to show that we know already that 1 and 5 right here are congruent angles. And we're going to use that. And we know that they're equal to each other and they're the same because of their corresponding angles. And we can go ahead and say that. Angles 1 is congruent to angle 5. This is the side work you should be doing every time you work on a proof. And why can we say that they're congruent? Because they're corresponding angles. All right, we already showed that earlier in the lesson. We're also going to say that angles 1 and 3 are linear pair, which makes sense, right? 1 and 3 is a linear pair because they sit on a straight line and they're adjacent to each other. So we can go ahead and say that angles 1 and angle 3 is a linear pair. And why can we say that? Well, that's the definition of a linear pair, right? So if I'm looking at this, I have corresponding angles. They're congruent. I have some things that are congruent. I've already showed my linear pair. So let's talk about what does that mean. So don't forget to convert this. So what does it mean to have angle 1 congruent to angle 5? Well, we know that the measure of angle 1 equals the measure of angle 5, because that's the definition of congruent angles. We know that 1 and 3 are linear pairs. So what exactly does that mean? The measure of angle 1 plus the measure of angle 3 equals 180 degrees, because that's a definition of supplementary angles. And I'm just going to shorthand it and abbreviate it for you. So since the measure of 1 and 5 are the same, I'm going to go ahead and substitute 5 for measure of angle 1 and say this, that the measure of angle 1 plus the measure of angle, the measure of angle 5 plus the measure of angle 3 equals 180. What did I just do here? I just substituted. I substituted for 5 for 1 because they're the same thing. It's like I'm paying with, instead of using the paper dollar bill, I'm using a coin dollar. It's the same thing. They're interchangeable, and I'm interchanging it right here. Well, look what I just did. I just showed that 3 and 5 are supplementary because they add up to 180 degrees. So we did our proof. Let's keep going. Let's look at another proof. In the Nearpod, go ahead and work in, try to fill in these blanks based off of the proof I just did for you. And I'm going to keep going. And what I want to do is work on alternate interior angles. And we're going to do that side work in the next page here on alternate interior angles. And if you remember, the side work was in the form of flowcharts. So you can use Madison's technique if you want on the Nearpod. Go ahead and do that, or come up with a totally different way of doing it. I'm okay with that. But what are we going to do here? We know that W and X is a parallel because that's what that notation means, and Z is a transversal. You got to establish that in your proof. And I want to prove that alternate interior angles are congruent. So what are our alternate interior angles? Well, we can go 3 and 6. We can go 5 and 4. Pick any one of those as you want to do. But looking at our flow chart, we also want to think about corresponding angles and vertical angles in this particular flow chart. So what are our corresponding angles? Well, we can think of 1 and 5. We can look at 3 and 7. We can go 2 and 6, or 4 and 8. Any of those to prove it, depending on which one of these angles you want to prove. So you know what I'm going to do? Let's focus on proving 3 and 6. that 3 and 6 are the alternate interior angles I want to prove, right? I want to prove that down here. That should be the final thing that you write. So I want to prove that angle 3 is congruent with angle 6. And look, I'm going to be using the transitive property. How's that going to work? Well, I need some equality here. So if I pick 1 and 5 for my corresponding angles, angles 1 is congruent to angle 5, then I need to find something that's equal to that. And so that's where the vertical angles kick in, right? Well, I can't do 1 and 5. What am I doing? I'm proving for 3 and 6. Let's do, let's go 3. Let's go 3 and 7. Three and 7 are corresponding. So since I'm proving 3 and 6, let's go ahead and say seven and 6 are our vertical angles. 7 is congruent to 6. And you can do it the other way around. Well, you see the transitive property in this, right? If 3 is the same as 7 and 7 is the same as 6, then I can go ahead and say that 3 is the same as 6. So we have our proof. We have our beginning stages of our proof. So what we want to do is go ahead and throw that onto a 2-column proof if we'd like. The last part of the Nearpod I want you to go dig through. There we go. Is Annabella, her proof. She got a 2-column proof here, and she went about it a little bit differently. We use corresponding angles, we use vertical angles to show that, but she's using supplementary angles. Try to take what she did here and put it here to prove that alternate interior angles are congruent. And then on the next slide after that, it'll be your answer. Compare your answers. So write this down on a piece of paper. All right. Well, that's all I got for you. Hopefully you are watching this video. Hopefully you are working on this Nearpod. Are these things that you should expect on a test? Yeah, you should expect these on a test. So make sure you pay close attention and take lots of notes. All right, I'm out.